With over 76 million units sold worldwide, Tamagotchi was one of the most popular toys of the 90s. In this video we are going to build our own digital pet using Arduino. There is a lot to cover, so let's get started. Hello guys, I am Nick and welcome to Educates TV, a channel that is all about do-it-yourself electronics projects with Arduino, Raspberry Pi, ESP8266 and other popular boards. Subscribe to the channel now if you don't want to miss any future video. In this video we will be making this, a Tamagotchi clone, the Tamaguino. As you can see on the small OLED display, we take care of a small dinosaur. Using the meters like the hunger meter, the happiness or discipline meter, we can determine how healthy and well behaved the dinosaur is. We can feed the dinosaur, play with it, visit the doctor when it gets sick and many more things. As you can see, the game offers great features and animations. It is a very addictive toy. I remember playing with a Tamagotchi for months when I was a kid. I still remember the day that my first Tamagotchi died. This project brings back so many memories from my childhood, and that's why I decided to build one. This project is developed by Alois, a friend from Serbia. He has done an amazing job. I discovered his work a few months ago. He has built a website where he shares everything about this project, the code, the schematic diagram, even a 3D printed enclosure for it. He has done a fantastic job in this project. Even if you are not interested in building the project, study the code. Alois is a very skilled developer, so you are going to learn a lot from his code. You will find a link for the project in the description of the video below. Let's now see how to build this project. You can build this project on a breadboard in just 5 minutes. Just use an Arduino Uno, an I2C OLED display, some buttons and a buzzer. If you are a long-time subscriber of this channel, I am sure you already have the above parts readily available for a quick test. You can see all the connection in this schematic diagram. If you want to have something more permanent like I did, you are going to need the following parts: an Arduino Pro Mini, an I2C OLED display, 3 push buttons, a small speaker or a buzzer, a switch, a LiPo battery charging board, a 150 mAh LiPo battery, a 10K resistor, a 7x5 cm prototyping board, an FTDI programmer and some wires. The cost of the electronics is less than $15. You can find links for all the parts in the description of the video below. First of all, let's build the electronics. I used this small 7x5 cm prototyping board to solder all the electronics together. It was the first time I was using a prototyping board in a project, so I didn't know how it was going to turn out. I first arranged all the parts on the prototyping board and then I started to solder the parts one after another. 1 hour later, everything was soldered. It turned out to be easier than I thought. It was then time to load the code to the Arduino Pro Mini. I used an FTDI programmer to load the code and everything was working fine. Then it was time to build the battery circuit. I used this small LiPo charging board that is capable of charging and protecting LiPo batteries. The default charging current that the board provides to the battery is 1000 mA. This is too big for our small battery. We are using a 150 mAh battery, so the charging current can't be more than 150 mA. So we have to remove this resistor here and replace it with a 10K one. This way we reduce the charging current to around 130 mA, which is ideal for the 150 mAh battery. Now it was time to move on to the enclosure. Even though I really like the enclosure that Alois provides, I decided not to use it for two reasons. It was the first time I was building something on a prototyping board, so building something so small was very difficult to me. Also, I really love 3D design, so I would love to design my own enclosure. I used Fusion 360 to design the enclosure, and that's the design I came up with. It consists of 5 parts: the base, the top cover, and 3 buttons. It is not my best looking design, but as I am building more projects and gain experience, my designs will improve. You can find links for the files of both the enclosure designs in the description of the video. Then it was time to 3D print the enclosure. I used 2 wood filaments in order to print the enclosure. I used Form Futura's Easy Wood Coconut and Birch filament. The enclosure uses around 70 grams of filament, so it will cost you around $5 if you print it at home. You can find links for the filaments in the description of the video. As you may have noticed, I use wood filaments in every project. I really love the texture and the color of wood filaments. So, after about 3 hours, all the parts were printed. Then it was time to sand them using fine sandpaper, a tedious and time-consuming process. After the sanding process was over, I applied wood varnish to all the parts and let them dry for 24 hours. The result was great. The parts look so cool with the varnish applied. Please don't skip the sanding and varnishing process. It will make your projects look impressive. Then it was time to put everything inside the enclosure. I first glued the prototyping board in place and then I glued the battery charging board and the switch. I attached the battery to the board using some standard glue. Don't use hot glue on a LiPo battery, you are going to destroy it. The next step was to solder the output pins from the battery charging cell to the Arduino Pro Mini power pins. Then I glued the buttons and lastly it was time to glue the top of the enclosure. The Tamagotchi project was ready. With the 150 mAh battery inside, the project can run on batteries for over 7 hours. Of course, we can easily recharge it in about 1 hour using a cell phone charger. Let's now take a quick look at the code. You can download the code from the project's website. I use the code which uses the internal pull-up resistors of the Arduino board, so we don't need to use any external resistors to make the project work. In order the project to compile, we need 2 familiar libraries, the Adafruit ZFX library and the Adafruit library for the OLED display. You can find links for the libraries in the description below. The code is about 1,300 lines long and it uses 95% of the available program memory. If we need to expand the code of the project, we are going to need to use another microcontroller with more memory available. I think it is impressive what a simple, low-cost Arduino board can achieve. As a final thought, I think that this is a great project, a project that demonstrates that makers can now build almost anything. It took Alois, the developer of the code, about 1 week to write the code in his free time. Open software and hardware enable us to do things that few years ago were impossible even to professionals. Building this project was a great learning experience for me. It was the first time I was using a prototyping board and the first time I was using a LiPo battery in a project. Also, I designed this enclosure from scratch, which was more difficult than I expected. To be honest, I am not satisfied with the enclosure. It is way too big for such a small display. That's why I am thinking to replace this small 1-inch OLED display with a bigger 2.4-inch display I have discovered. I think it will make the project much better. I would like this project to evolve into an Arduino game console. This project is a good start. I would love to hear your opinion about this project. Do you have any improvement suggestions? Please post your comments in the comment section below and don't forget to like the video if you find it interesting. Also, consider subscribing to the channel and do click that bell or YouTube might not show you updates as new videos come out. If you are going to be shopping for parts, check out the affiliate links from the video description. That's it for today guys, thank you very much for watching, I'll see you in the next video.